Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we have another topic, that is advantages of dimensions. Okay. Actually, this is called the applications of dimensions, or this is called advantages of dimension. Okay. So, what is the advantages of dimension? To derive the formula, to check the homogeneity of an equation and to check the correctness of formula. Okay, so these are the advantages of dimensions. These are the uses of dimensions. So dimension has three uses. Okay, look at the third one, to check the correctness of a formula. For example, if we have a question that what is the formula for the speed, look at option A. Option A is GH by lambda under root. Option B is G lambda under root. Option C is A by X under root. Option D is P by rho G under root. Option D is none. Okay, so we have to check what is the correct formula for the speed. This is actually speed, and they ask for the correct formula for the speed. Okay, so let us discuss the speed. What is the unit of speed? Meter per second, we know that. Yes. What is the dimension of meter? That is length, L square bracket. Dimension of second, T square bracket, and shifted the T into numerator, so its power will be negative. So its power is negative. And write it in 1 square bracket, that is LT minus 1. Okay, that is the dimension of speed. Now let us take option A. We are checking whether option A is correct or not. Okay, so we are talking about option A. Option A is GH by lambda under root. Okay, now tell me, what is the unit of G? Meter per second square. What is the unit of H? Meter. What is the unit of lambda? Meter. Okay, the unit of G is meter per second square, the unit of H is meter, the unit of lambda is meter. Okay, so meter is cancelled out, so it is meter per second square under root. Okay, so it means that these dimensions are L power 1 over 2, L power 1 over 2 and T power minus 1. Okay, these are the dimension of this equation. So it means that these are not the dimension of speed. The dimension of speed is LT minus 1. So it means that this formula is wrong. Okay, now we are checking option B. Okay, look at option B. Option B is G lambda under root. Okay, what is the unit of G? Meter per second square. What is the unit of lambda? Meter. Okay, so meter square per second square. Okay, so square will be cancelled with the under root, so it will be meter per second. Okay, dimension of meter is L square bracket, dimension of second is T square bracket, so shifted T into numerator, so its power will be negative. So its power is negative. Okay, so write down in the 1 square bracket, so that will be LT minus 1. Okay, so these are the dimension of speed. So if these are the dimension of speed, so it means that option B is the correct formula for the speed, and this is the correct formula for the speed of the waves in ocean. Speed of the waves in ocean, this is the correct formula for the speed. Okay, now look at the second application. The second application is to check the homogeneity of an equation. To check the homogeneity of an equation. What is meant by homogeneity? Remember, homogeneity. What is meant by homogeneity? Okay, first remember, all the equation all the equation in physics are homogeneous. All the equation in physics are homogeneous. What does it mean? Homogeneous means the nature of left hand side will be equal to the nature of right hand side. Okay, homogeneity means the nature of the left hand side will be equal to the nature of the right hand side. Okay, what does it mean? It means that if left hand side consists of acceleration, so right hand side should have acceleration. मतलब लेफ्ट साइड पे अगर एक्सेलरेशन है तो राइट साइड पर भी एक्सेलरेशन, लेफ्ट साइड पर फोर्स है तो राइट साइड पर भी फोर्स, लेफ्ट साइड पर एनर्जी है तो राइट साइड पर भी एनर्जी. दैट इज कॉल्ड होमोजेनियस इक्वेशन. फॉर एग्जांपल हमसे ये कह रहे हैं कि चेक करो कि ये इक्वेशन होमोजेनियस है या नहीं है. तो मैं चेक करूंगा कि लेफ्ट साइड पे स्पीड है तो राइट साइड भी स्पीड होना चाहिए. अगर लेफ्ट साइड पे स्पीड है, राइट साइड पे स्पीड है, तो दिस इक्वेशन विल बी होमोजेनियस. ओके, सो लुक एट हियर. What is the unit of speed? Meter per second. Dimension LT minus 1. Okay. Now taking right hand side is AX. So what is the unit of A? Meter per second square. What is the unit of X? Meter under root. So meter square per second square. Square will be cancelled with under root. So it is meter per second. So its dimension are LT minus 1. So it means that left hand sides are the dimension of speed and right hand sides are the dimension of speed. It means that these left hand side is a speed, right hand side is a speed, so both have the same nature. So this equation is homogeneous. This equation is homogeneous. Let us take another example. For example, let us discuss the Einstein famous equation, that is E is equal to mc square. Okay. Suppose remove the square from here. So the equation will be E is equal to mc. The equation will be is equal to mc. Okay. Suppose remove the square from here. So taking left hand side is energy. What is the unit of energy? Joule. What is joule? Newton meter. joule किसके बराबर है? न्यूटन मीटर. वी नो दैट. ओके. और न्यूटन किसके बराबर है? न्यूटन बराबर है किलोग्राम मीटर पर सेकेंड स्क्वायर. एंड मीटर एज इट इज, सो इट विल बी किलोग्राम meter square per second square. So these dimensions are ml square t minus 2. These are dimension of left hand side. Okay. Now taking right hand side is mc. What is the unit of c? No. What is the unit of mass? Kilogram. What is the unit of c? Meter per second. So these dimensions are ml t minus 1. Okay. So look at here. Left hand side has dimension of energy and the right hand side has dimension of momentum. These are the dimension of energy, these are the dimension of momentum. So it means that left hand side is energy, right hand side is the momentum. So it means that both have different nature. If both have different nature, so this equation is inhomogeneous. So this equation is not homogeneous. So it means that we should place a square on the C. So why the square is there on the C? To make the equation homogeneous. Because if the left hand side is an energy, the right hand side must be an energy. So that is why we place a square on the C. Okay. So this is all about homogeneity or homogeneous equation. Now, another application is to derive the formula. Okay. Now we are going to derive the formula by dimensions. Okay. The question is they say that the drag force depends upon viscosity, the drag force depends upon radius, and the drag force depend upon instantaneous speed. So derive the formula for the drag force. Okay, so we have to derive the formula for the drag force. So they say drag force depend upon viscosity, drag force depend upon radius, drag force depend upon instantaneous speed. Okay, so we have to derive the formula by dimensions. Okay, now we are going to derive the formula by dimension. Okay, so combine all these three equations, combine these equations, so we will get F is proportional to eta RV. Okay, now if I remove the proportional sign, I'll place constant, I'll place K constant. Okay, look at here, we don't know about the viscosity, whether it is directly proportional or inversely proportional. We don't know about the radius, whether it is directly proportional or inversely proportional. The same is the case with the velocity, with the instantaneous speed. We don't know about its relation. Okay, so if viscosity has power +1, the power of viscosity is +1, it means that viscosity is directly proportional with the drag force. If the power of the radius is -1, it means that radius is inversely proportional to drag force. If the power of this on the speed is 1/2, it means that +1/2 means that instantaneous speed and directly proportional and drag force, instantaneous speed and drag force are directly proportional, but with the square root, because there is a power 1/2. Okay, now again look at again. Suppose if the power of the viscosity is -1, what does it mean? That it means that viscosity is inversely proportional to drag force. If the radius has power -1, it means that radius is inversely proportional to drag force. If instantaneous speed has power -1, it means that drag force is inversely proportional to instantaneous speed. But the confusion is, we don't know about viscosity, radius and instantaneous speed, whether they are directly proportional to the drag force or inversely proportional to drag force. So that is why I'll place powers A, B, C on these three terms. So I placed A, B, C, D, the exponents of these terms. So it means that we don't know about these powers, we don't know about these the values of these powers. So we have to find out the value of A, the value of B and the value of C. Then we can say that these are directly or inversely proportional. Okay, so this is our task. So we have to find out the exponents, we have to find out the A, B and C. Okay, so now putting the units of these terms. So what is the unit of force? Newton. What is the unit of viscosity? Newton second per meter square, whole power A. What is the unit of radius? Meter power B. What is the unit of speed? Meter per second, whole power C. Okay, so tell me, okay, what is Newton? Newton is equal to kilogram meter per second square. Okay, and here Newton is equal to kilogram meter per second square, and second as it is, meter square as it is, whole power A, meter power B, meter power C, second power C. Okay, now look at here, meter square cancelled, second square cancelled. So what we will have, look, kilogram meter per second square is equal to K constant, kilogram power A, second power A, meter power A. Okay, meter power B, meter power C, second power C. Okay, now convert these terms into dimensions. The dimension of kilogram is m square bracket, yes. Dimension of meter is L square bracket, yes. Dimension of second square is T minus 2, because if we shift the second into the numerator, so its power will be negative. Okay, now look at here, what are the dimension of kilogram? M square bracket, but kilogram has power A, so it will be m power A. So what is the dimension of second? So it will be T power minus A, because we have to shift into the numerator. So what is the dimension of meter? L power minus A. What is the dimension of meter? L power B. What is the dimension of meter? L power C. What is the dimension of second? T power minus C. Okay. So here I put the dimensions. Okay, I use the dimensions instead of units. Okay, now we know that base is same, power will be added. So here we have same base T and T, same base is L, L, L. Okay, so base is same, power will be added. So what will we have? Look, M power 1, L power 1, T power minus 2, M power A, T power minus A minus C. Look at here, there is first T power minus A, and the second T is T power minus C. So base same, power will be added. So it will be minus A minus C. Okay. So look at L. The power of L will be added, minus A plus B plus C. Okay. Now comparing the powers. Comparing the powers. Okay, now we have to compare the powers. Okay, so look at here, we are going to compare the powers. So look at here, the power of M is A, and here the power of M is 1. Here the power of M is A, here the power of M is 1. So it means that A is equal to 1. Okay. And here the power of T is minus A minus C. Okay. Minus A minus C. And here the power of T is minus 2. Okay, it is minus 2. So shift this A into right hand side, so it will be plus A. Here A is minus. If we shift it on the other side, it will be plus. So what is the value of A? The value of A is known, which is 1. So it will be minus C is equal to minus 1. So C is equal to plus 1. C is known. A is known, C is known. Okay. Now look at the power of L. The power of L is minus A plus B plus C, and here the power of L is 1. So it means that minus A plus B plus C is equal to 1. Okay. So we compare the powers. Okay. So what is the value of A? 1. What is the value of C? 1. So 1 and 1 is cancelled. So B is also equal to 1. Okay. A is equal to 1. C is equal to 1. B is equal to 1. Putting these values in equation number 1. Putting these values in equation number 1, we get. Okay. So it will be eta power 1, radius power 1, speed power 1. So if the powers are plus 1, plus 1, plus 1, it means that all these three terms are directly proportional. So that is the correct formula for the drag force. We derive the correct formula for the drag force by dimensions. If we know the power, that is plus 1, plus 1, plus 1, it means that these terms are directly proportional with the drag force. This term is also directly proportional with the drag force. This term is also directly proportional to the drag force. Okay, this is all about dimensions. Inshallah, we will talk about the exercise in the next video. Okay, take care. Allah Hafiz.